Here's another calculate the equilibrium constant problem where you don't really need to use an ice table. An aqueous solution of ethanol and acetic acid, each at a concentration of 0.810 molar. That's ethanol, acetic acid, the two reactants, is heated to 100 degrees Celsius. They need to point out that it's a constant temperature. At equilibrium, the acetic acid concentration, that's that again. Notice they didn't say a thing about the product, which is called ethyl acetate. This is an esterification reaction. Is now 0.748. So they're giving you two pieces of data for acetic acid, the beginning and the equilibrium. You also know the beginning concentration of this. We don't know a thing about that, and yet they say calculate K for the reaction. You can see that we're going to use stoichiometric relationships to deduce a lot of things here. Calculate K for the reaction. So set up the equilibrium constant expression. Does anything get omitted? You betcha, water. Do we need any exponents? No, coefficients are all 1. So there's our setup. Products over reactants. And this is equilibrium constant is at equilibrium. So the only piece of data that's useful right now is that, the equilibrium concentration of acetic acid. However, note that it went down a little bit by 0.06 or so. So if this goes down by 0.06, yes, you might be able to predict that the concentration of the other reactant goes down by 0.06, and since it's a 1-to-1 relationship, the concentration of the product goes up by about 0.06. So that's it, 0.062. And so put them each in. So it's definitely the same concentration, so it's 0.748 squared on the bottom, and it went up by 0.06 from nothing at all for ethyl acetate, and so there's your final answer. Bada bing. The ice table method does the exact same thing. It takes longer, but it shows everything very clearly. Here's your balanced chemical reaction. It's the same situation. You know, if you didn't have this known already, you'd start by saying, what is it I know and don't know? Ooh, two things. Looks unsolvable, but stoichiometrically there's a lot you can deduce. So there's your balanced chemical reaction. You're going to cross that one out or not even include it because that's out of solution. And the initial concentrations are given. The change for acetic acid is given. And therefore we can say that if that went down by 0.062 and it's a 1-to-1 ratio, it goes down by the same amount. If it was a 2 in front of this, it would have gone down by twice that. But there's not. And the 1-to-1-to-1, the product concentration must increase by the same amount because of that stoichiometric relationship, giving us all three numbers. We can now plug in and you get the same number. So choose either method. I really like the fast way whenever you can get away with it. All right, that's another equilibrium problem.